Hi guys and welcome to my channel. Today I'm going to be creating my first ever video on x86 assembly. You may have seen resources about assembly online. However, when reading them or listening to them, you don't really seem to understand the concept of assembly and how assembly works. So I've created this guide in order to explain assembly through the eyes of a beginner, so I can explain everything as a beginner to a beginner. It also allows you guys to watch my videos and progress with me as I learn new things. So let's get started. So what is assembly? Assembly is a low-level programming language, as opposed to higher-level programming languages such as Python, PHP, JavaScript, CSS, etc. Assembly is essentially a human-understandable form of machine code, since programming in ones and zeros would be way too complex for any programmer. So, what is assembly useful for? Well, it's useful for reverse engineering and writing shellcode. It also allows the programmer to directly communicate with a CPU in order to perform a very specific task. Since almost every language is compiled to machine code, and assembly is the readable version of machine code, it truly allows you to understand almost any application and what that application is doing, which is why it's useful for reverse engineering. Now that I've explained the basic concept of assembly, let's start getting into the overview of how assembly works. So let's first look at instructions. So since the programmer is directly communicating with the CPU when writing assembly, this makes assembly very CPU specific. Not only that, but as companies such as Intel or AMD create a new version of a processor, they may need to add additional instructions to the processing unit. So what are instructions? Instructions are something that the manufacturer of the CPU has left for us in order for us to complete operations. So if we wanted to move a value or some data into a register, I would use the MOV instruction, which is short for move. If I wanted to add data into memory, I would use the push instruction. A list of instructions can be found below. This link will also be in the description. You may have heard me just mention registers when I said you can move data into a register. Now I'm going to be explaining what registers are. So registers are like variables that are built into the processor. Using registers instead of memory to store values make the process faster and cleaner. However, registers aren't meant to be a permanent place to store data. It's for quickly performing an operation and then executing an operation. Here are a list of 32-bit general purpose registers. We will get more into this later as I give a practical example when we start programming in assembly. So the 32-bit general purpose registers are EAX, EBX, ECX and EDX. 64-bit general purpose registers start with an R, so RAX, RBX, RCX, RDX. However, we're writing 32-bit assembly, meaning we don't need to use any of the 64-bit registers. Also, a list of 32-bit registers can be found on the link below, which I'll leave in the description. So this might be getting confusing, however let's do a rerun of what we've learned. So we know that CPUs have instructions that have been created by the manufacturer in order to complete operations. So we have operations such as MOV for move that I mentioned earlier. We have some other ones that I didn't mention like ADD, add, so we can add things. We have SUB to subtract things. All these operations can be found in the link below, as I mentioned before, with all the descriptions on what they do and what kind of operations they perform. And then we also mention registers, which allow us to store values instead of using memory to quickly perform a task. So you may not know any assembly, but from what we've just learned, we know how to perform an operation or an instruction on a register. So if we know a register like EAX can store data in it, and we know how to move with MOV, we can move EAX, the value from that, which could be hello world, into EBX. So we could write MOV space EBX, comma, space EAX, which means move EAX, the value of EAX, into EBX, which is pretty simple. So we know that we can perform operations with values in registers. However, what if we wanted to perform a task? We only have 4 registers that we can store data into. We might need more places to store our data, so this is where the stack comes into play. So what is the stack? The stack is a region in RAM that stores data for your application. It follows the LFIO, the last in, first out layout. As the name implies, it's a stack, like a stack of books or even a stack of plates, like the photo on the right. Data is stored in each one of those plates. This structure makes it very easy to take an item off of the top of the stack, while getting to an item deeper in the stack may require taking off multiple other plates first. Let's get started and actually program something in assembly. So we're going to create a simple application in assembly that will print the text "Hello World" to our terminal. Right, so let's get started. So what we're going to be creating is a simple application. Once executed, it will output text to our terminal. As you can see right now, I am inside of a Linux environment. I'm running Kali Linux inside of a virtual machine. You're going to need to be on Linux for this tutorial because we're going to be writing our code for Linux. So this won't work on Windows, so make sure you're in a Linux environment for this tutorial right here. So once we have that ready, we're going to get started. So you're going to want to open up a terminal, and you're going to do whatever your packet manager is. So mine's apt, so I'm going to do sudo apt install. I'm going to install nasm. Nasm will essentially compile our assembly code into machine code so we can run it. So I'm going to exit that. Okay, so once you've got nasm installed, you're going to want to create a folder. This can be called whatever you want it to, and it can be placed wherever you want it to. And then you're going to open this up in your IDE. So you're going to want to make two files in here. You're going to want to make something called makefile, all one word, makefile, and it's going to look like this. I'll put this code down in the description to save you from typing it out. But essentially what it does is when we type in make down here in our terminal, it will automate the whole process of turning our assembly code into an executable, so we don't need to type out these commands every time. So once we have that done, we're going to create tut.asm. So create a new file and call it tut.asm. And this is where our assembly code is going to be. So what we're actually going to do is we're going to define a global, and it's going to be start. So we're going to do that, and then we're going to do section. So we're going to create a new section, and this is going to be called data. So we're going to create a new section of data, and the text we're going to want to output to the terminal, the message, we're going to call here. So we're going to call it message, and we're going to put hello world in here, and then we're going to do the ASCII equivalent, which is this. That's new line, and then this is a null terminator, so it just nulls out that string, just ends it. So we've got hello world, new line, and then nulls it. And now we're going to want to calculate the length. So we're going to call this length, and then we're going to do EQU $- message. So this actually gets the length of the message. And then once we have that done, we're going to go down here and we're going to do start. So assembly is pretty lenient in the sense of it doesn't need to be uppercase, lowercase, it doesn't need to be indented, all that kind of stuff. So let's get started. So we're going to do _start, and we're going to do move, and we're going to want to move something into the EAX register. And you're wondering, okay, what's this going to be? So if we can remember here from our list, which is in the description, our list of instructions we just used is MOV, which is move, and the description is copies data from one location to another. So what we're going to want to do, here's our general purpose registers. So we've got EAX, EBX, ECX, and EDX. What we're going to do, this will start to make sense. So here, I'll leave this in the description as well. This is a bunch of system calls. So essentially, what we're wanting to do is wanting to write text to our terminal. So we're actually going to select this one here, syswrite, and it writes to a file descriptor. So the function in this C file is sys_write, and it takes in a file descriptor, it takes in a char, which will be our text, and it takes in a size, which is why we calculated here, why we got the length of our message, because we need to specify the size of our message. So what we're going to do is we're going to move for, which is the sys_write. So a syscall is essentially, we can just execute functions that are built into Linux in order to perform a task. So we're going to move, so we're going to do comma for. So we're going to move for into EAX. So we're not moving EAX into for. It's always done right to left. So the value is on the right, the destination is on the left. So we're going to move for into EAX. And then what we're going to do is we're going to do MOV EBX. This is essentially what EBX is. So we just did EAX for, which calls this function here. And then EB, so you got EA EBECED. This is the file descriptor, so we're just going to put 1, and we're going to go down, and then we're going to do move ECX, so we're going to move our message into the second parameter. So this is the function, so I'm actually going to comment this. You can do that by semicolon. So I'm just going to put system_write function, and then it takes in a file descriptor. It takes in here, which is our char. So this is our char, this is our message, and we're going to do move edx, and we're actually going to do the length, because let's just put this here, length. So the syswrite function, this is argument 1 that gets passed through, this is argument 2 that gets passed through that function, and this is argument 3, which, as you can see here, argument 1, 2 and 3. Okay, so once we've done that, so we've got that done, we're going to want to execute this. So how we execute it is in x86. So in order to execute a system call, so execute this function here, we're going to want to do in x86, and then we're going to do move EAX, and we're going to do 1, which if we go back to here, 1 is a sysexit. So we're going to do and then we've got the status here, so move EAX1, move EBX1, so that's the status. So we just called system, so we executed our syswrite, which is going to write to terminal. It's going to write our message and the length. We're going to execute that here, and then we're going to move 1 into EAX and then 1 into EBX, which is essentially system exit, and then the status in there, and then we're actually going to execute that. So we're going to execute that sys function, that syscall, sorry. So once we have that done, we're going to type in here make. So we just made it, and then we're going to do ls. We can see here we have a executable, so /tut hello world. Woo! So it honestly is pretty simple. So if you really wanted to do more, you could go down to one of these. I'll leave this link in the description. But you've got a bunch of things down here, like if we type in makedir for make a directory, so 39, so we go down to here, so here we are. It just takes a path name and a mode, so let's actually take that, so 39. So if we wanted to make a folder, we'll quickly do this, so I'll show you how this works. So we're going to execute a syscall, so we're going to do move EAX, which is our first register, and we're going to move 39 into EAX, which calls make directory. So we're going to make a directory, and we're going to do move EBX, and we're going to call this, we'll actually put it with message, so our folder, our directory is going to be called message. And then the next thing in this system call, which if we go down, is, so we've got the path name, which is like the folder name, and then we have mode. So let's do move ECX, and then do 0777, and then we'll do in x86. So here we've got the syscall, we've got param1, and then param2. So parameter 1, parameter 2, and then we have execute. So if we do make again and just do tut, oh, segmentation fault, but however it did create, it's because we put a null terminate and a new line, and it didn't really understand that. But we have the folder hello world now, and we put the permission of 0777 there, so we can actually cd into that. So yeah, that was the first episode on assembly. It isn't too difficult. This tutorial or guide might not have explained everything, but I tried explaining it as simplest as I could. So I hope you liked it. If you did like it and you want to see more and you want to progress with me, I'll get better at these as well. So yeah, if you liked it, subscribe and like, and I'll be doing episode 2. Yeah, so thanks for watching. Bye.